Multi-level modeling is one of the possible solutions for the problem of the hierarchical structure of the data. Let's see what's that problem. Let's consider first a simple case in which there is only one level, so there is no hierarchical structure. This is the typical case in which we've got a number of participants. Here, for illustration purposes, we only have 8. And two variables. One we call independent variable, the other one dependent variable. In this case, the independent variable is self-confidence and the dependent variable is motivation. So we want to establish the relationship or predicting motivation based on self-confidence, so we can have a linear model, a regression model with motivation as dependent or outcome variable and self-confidence as independent or predictor variable. There is no problem here. But what happens when we add one level to the structure of the data? Suppose that these 8 participants are students who belong to different schools. So the first 2 students belong to school A, students 3 and 4 to school B, students 5 and 6 to school C, and 7 and 8 to school D. Now, we added one level to the structure of the data. So, is this a problem? Well, that poses a number of problems. But before going through the problems, I want to show you that there are many ways in which this structure can occur. So in this case, the participants, instead of being level 1, they are level 2 of the structure. And the independent variable, instead of being a numerical variable, is a nominal variable. So this is in a case in which we would normally do a t-test or an ANOVA. So multi-level modeling applies to this situation as well. Now, what about participant as level 2? Well, when participant is level 2, then there is another level 1, which is not the participant, which is the observation. And in this case, it's an experiment. This is a typical structure of experimental studies in which we've got a number of participants, but for illustration purposes, we only have a participant 1 and 2. And we have 4 observations in participant 1 and 4 observations in participant 2. So then we want to investigate the role of the format of presentation of information on accuracy. And we've got 2 levels in format, words and images. So each participant contributes 2 measurements to each of the levels of the independent variable. Now, typically, we only have, this would be a repeated measures designs, but we also have 2 observations within each level of the independent variable. So what do we do here? But first of all, what are the problems? Why is this a problem? Well, the problem is that if we use all the data, we violate the requirement of independence of the data for many of the analyses we want to do. So analyses that require the use of a linear model. That is because values that belong to the same instance at a higher level, so in the first example, school is the higher instance, the instance at the higher level, and in the second case is participant is at level 2. So the observations in participants and students who belong to the same school are correlated. So they tend to be more similar than observations on other schools. And even more important, within each participant, the observations are correlated as well. So the observations within each participant are more similar to each other than observations within other participants. So if we use all the data to do the analysis, then we are violating this requirement of independence of the data. So the other problem is that, well, if we average the data at level 1 to have one value in each instance at level 2, we lose a lot of data. However, this is commonly done. An alternative is to analyze the data separately at each instance of level 2. But if we do that, in some cases this is not possible. It's not necessarily the thing that we want to do, that we want to analyze. And also it requires the estimation of a large number of parameters. So for example, if we have 100 participants and we have 10 observations within each participant, then we have to do a linear model for each participant, because that's at level 2. And that is sometimes not informative, and it requires the estimation of a lot of parameters. Now, multi-level modeling provides a solution to this problem.